Welcome. We're going to have a look at some maths today, and we're going to look at circle theorems. There are quite a few circle theorems, and they're not that difficult. The hardest bit, of course, is you've got to know them. So let's have a look at what the circle theorems are, and then look at a few problems and see if we can solve them. Let's have a look. So let's start with something fairly easy, which is going to be a circle. When I normally teach this, I normally draw these by hand, but I thought I would help by trying to put these in. Right, let's look at some ideas of what we can actually do with a circle. And one of the things we have with a circle is that we meet something like a tangent. So this is a tangent to the circle, and it meets a radius at 90 degrees. So tangent is a radius of a circle at 90 degrees. So there's our 90 degrees, and here is O, our center of our circle, and there's our tangent. Okay. Fairly easy one, that one. And let's look at another one. Yeah, it's going to be one of those days, I can see that. Right, students trying to draw circles are quite normally amusing, sort of trying to watch. And my hand's in the way doing that one. Basically, if you've got a compass, and I'd always recommend going for a compass like this, which has got the pencil lead built in, then we just hold it by this little bit up here, and circles are much easier to try and draw. Okay, another one then. Let's take our radius, and what we're going to do is we're going to go out to the circumference, and then let's draw a line at 90 degrees. I'm going to put that line on there to make sure it's 90 degrees across here. So this is both 90 degrees. So this is here our chord. This here our radius. And the radius, when it meets the chord, it bisects it. So when a radius meets a chord at 90 degrees, chord is bisected. Similarly, we could have said that when a radius bisects a chord, then it will do so at 90 degrees. And we can talk about these either way. Okay, so there's a couple of really quite easy little circle theorems. Let's bring in another one. I'm sometimes asked by students how many there are, and it depends on the way that you look at these, whether we can do them in sort of one name or two names. Right, okay, so let's have a nice easy one, and this time let's draw in a tangent to the circle. There we are, one tangent to the circle. Let's draw in another tangent to the circle. And just as before, we're going to put in our radii. Now, what can we see about this? Well, we know this is 90 degrees. We know this is 90 degrees. We know this is a quadrilateral. So I can also work out from this one, before I do anything else, that if this is angle X and this is angle Y, since this will all add up to 360 degrees, being a quadrilateral, then if these two are 90, then X and Y will equal 180 degrees. What we also get from this is that this and this, these two tangents are equal. So they're equal length. Just fell off the side. So we can see that they are quite easy. And we can have lots of questions based on this. Okay, so there's a couple of sort of facts of circles. Let's look at really some theorems. Let's bring the paper down a bit so you can see. And let's draw in a nice little circle. And we'll start with one of my favorite ones. So I'm just going to draw in two radii, and then let's draw in from here up to the circumference. I always tell students this is my Star Trek sign, but they look at me rather blank and don't know what it is. However, what I can tell you is that if we look at this angle, X, this angle here is 2x. So we can say for this very simply that the angle at this circumference here is going to be half the angle at the center. Or we could have written that to say the angle at the center is going to be twice that of the angle at the circumference. And we're seeing that we're getting 2 for the price of 1. Let's draw another one. we'll start off the same way. Well, it seems to have gone very blue. Don't know what we did to the light there. And let's draw in another one. And we see this peculiar sort of shape. And we think, right, what can we say about this? But in fact, nothing really has changed on this. What we've got is this angle has gone down a bit. I'm just going to sharpen my pencil because we've seen that this point at the top really has just moved round here. And so if I put in angle X here, then this angle here is still 2x. And it's the same circle theorem. It's just pushed round a little bit. And you have to see that that one is the same as that one. Let's draw another variant of this. Let's take 2 radii. But this time we're going to go down this way. And I deliberately haven't made them equal. I could have, but I didn't want to mislead you. Because it's the same thing. This line here has moved now all the way round to here. And we can say that this angle here, this angle X, is now half of that one. Or the angle at the center is twice this one. And all of this is the same circle theorem. Basically, the angle at the center of the circle is twice the angle at the circumference. And the rule is when they are subtended by the same arc. Right, let's move on and have a look at the next circle theorem. Just draw in a circle. And this time I'm going to draw in a diameter. If we take a semicircle and we draw any particular angle to the circumference, then this angle will be 90 degrees. So the angle in a semicircle is a right angle. You'll notice I'm not bothering to number my circle theorems. Basically, we don't need to, because they're just the circle theorems known by their names. There isn't something like Theorem 1, Theorem 2. Different books put them in different orders. These we will need to perhaps prove a little bit later on, but we'll worry about that later. So let's have a look at another one of these theorems. So our next one, quite easy. Let's just draw in my circle again. And here, what I'm going to do is I'm going to draw in, I'll do it this way. The chord, we have now two segments of the circle. We've got a small segment and we've got a large segment, sometimes called the major segment and the minor segment. Going up here, we'll draw in a line to make a triangle. And we'll do another one. Trying to make sure they're different. I'm not trying to give any illusion they're the same, but we can say that this angle here and this angle here are both the same. You can say that the angle here on the same segment these angles are equal. And if I do something rather daft and I turn my piece of paper completely upside down, and we thought of this side here as a different segment, then I can see that these two angles are also equal. I'll put it the right way up. So angle Y will equal angle Y. So we've got another one we can have a look at. Let's draw in yet another circle. One of my favorite of these is the Cyclic Quadrilateral. I'm just going to draw in a quadrilateral in this circle. And it certainly won't make a square, but it does make rather an interesting sort of shape. Not any particular shape. I've tried to make that one fairly irregular. And what we know is the opposite angles of a cyclic quadrilateral add up to 180 degrees. There. So we could get some interesting other points here. Okay. Let's have a look at another one. This time I'm going to have a tangent, and in this tangent let's draw in a triangle. This is known as the alternate angle theorem. Here we've got these two angles here, x and x, and they're equal. So for this one, we can say that the angle between the tangent and a chord at a tangent, let's do it right. Here is equal to the angle in the alternate segment. So here is another angle in a different segment. So can't spell. So alternate angle theorem, which gives us a whole load of different things that we've actually met. So we've met here 1, 2, 3, 4, 5, 6, 7, and 8. So I've given you there several different theorems to have a look at. Now, there are a few other ones that we come across, and I might deal with those a little bit later. But let's have a look at now a little problem. We'll try and have a look at sort of a sample sort of problem that we can do, that we might meet, and we have to try and solve. And what we have to do is look at our problem and see basically what we can do with it, whether we can identify what is going on. So let's draw ourselves in a particular question. So let's think of a nasty question that we might have, and someone might give us a typical bow tie problem. So here we've got what looks like a bow tie. It's not going through the center. The center is a different place. And let's have some angles that they give us. And then someone says, well, that's 40 degrees. Okay. And that one's going to be, I don't know, 65 degrees. And what we're asked to work out is, can we work out this angle? Can we work out that angle? Can we work out that angle? And the answer is, yeah, fairly simply. Let's look at what we've got. Well, this is our angles in the same segment. If I turn this round, then if I draw my segment in here, then if this angle is 40, then angle A will be 40. And as I do so, I need to give a reason. And these are angles in the same segment. Similarly, if I look at this one round this way, then if this angle is 65, then that angle is 65. Same reason. How about angle B? Well, that's now easy to calculate because angle B, it's the angles in a triangle I'm going to cheat. And they add up to 180 degrees. So therefore I've got here 180 degrees minus my 40 plus 65. That's going to make 105. Take 105 away from 80 is going to give me 75. So what looked horrible is in fact one of these nice questions that we can manage to get all sorts of easy things out. This is one of my favorite little questions that comes up quite often. And what we have is a cyclic quadrilateral. But when they draw the cyclic quadrilateral, they accidentally make that line a little bit longer. So let's work out one of these angles. Let's just be given one of these angles, and let's suppose this angle is going to be, just having a look at it, it's going to be, we'll pretend it's going to be 80 degrees. Well, if this angle is 80 degrees, then the other angle here has got to be, we'll call it A. This angle is going to be 180 minus the 80 degrees. So if I want to look at this one, if I want to look at angle A, we can say that angle A is going to be 100 degrees. And the reason, these are the angles in a straight line. How about if I wanted to work out what angle B is? Well, we know that angle B, angle A plus angle B are going to make 180. So angle B will equal 80. And this is because the angles in a cyclic quadrilateral add up to 180 degrees. What we can also see is that angle B and angle there labeled 80 will actually be the same. All right, let's try ourselves with something that's sort of going to be looking a bit horrible. Let's just try a few more of these. In each of these cases, we're trying to look at something to see what we can say about it. Let's draw in a line. It's going to go through the center. It's going to be a diameter. Let's draw in a radius. And let's draw in another triangle. I always recommend you try and draw some of these if you can, because it does make life easier. Right, so let's see what we would know if we're given a problem like this. Well, let's suppose we're given this angle as 22 degrees. And we'll have this angle at, 48 degrees. And we'll be asked to work out what angle A is and what angle B is. Yeah, another typical problem. Well, let's see what we know. I know that this is a radius and this is a radius. So therefore, this triangle here is an isosceles triangle. So because I've got myself a little isosceles triangle, what can we say about this? Well, if this angle is 22, then this angle also has to be 22, because we've got the isosceles triangle. Therefore, this other angle up here, angle A, is going to equal 180, because it's the angles in a triangle, minus the 22 plus 22. And that's going to give us 44. And we can take then the 180 minus the 44. And that's going to give us 136 degrees. Let's look at the other triangle. Well, this triangle here, we know this is a diameter. If this is a diameter, then we can say that the angles in a semicircle, can't spell, equals 90 degrees. It's a right angle. If that's a right angle, then we know two angles of my triangle, so I can work out the third, and we know that the angles in a triangle and up to 180 degrees. Could have put that one in there as well. And so we know that we've got simply here 90 minus 48. And we can quickly work that one out. Right, 52 then, 42. There we are. There's three little ones that we've gone and had a look at. Let's look at something a little bit nastier. Let's suppose we've got a little line here. What should we have? The advantage of trying to draw these out is you can see sometimes what the construction is. Change my mind. Let's extend this chord out. And I'm going to make this right. Okay, let's see what I've got. Now, quite often when they give you one of these questions, they give you some facts that don't quite fit the diagram. Oh, I'm going to do that because I haven't quite drawn this right. But I'm going to say that that line equals that line. All right? And I'm going to give you an angle here. And let's suppose that's going to be, oh yeah, let's make that 70 degrees. And we'll have another one. And we'll say that this is going to be 50 degrees. What have I got to find? Well, let's find this angle, A, and let's see if we can find another angle. Let's do this one here, B. Oh, well, I've made my life really quite easy, haven't I? Because these are the angles in the same segment. So I can say that angle B equals 50 degrees. And the reason it's going to equal 50 degrees is they are the angles in the same segment. So that was nice and easy. Now I've got to try and work out what A is going to be. Well, not many clues here. Let's see what we can achieve. Well, if I look at angle A here, let's see if I can just take out that particular triangle. And I've just taken out certain bits of it. I know that's 70 degrees. This question is A. And what else do I know? Well, I know if I draw this out, I already know what B is. That is 50 degrees. This angle is going to be 70 degrees down here. Why is it going to be 70 degrees? Because this is an isosceles triangle. Spelling's not obviously very good on a Monday morning. If this is 70, this is 70, then this one has to be 40. How? Well, angles in a triangle equal 180 degrees, so that's going to be 180 degrees minus 70 plus 70. That means that this angle here altogether is going to be 90 degrees. And if this angle is 70, this angle is 90, then because the angles in a triangle again make 180 degrees, therefore I've got a triangle here, 90, 70, so therefore this one is going to be 20 degrees. By breaking the problem down into little steps, we can solve quite difficult problems. We'll have a go at one more. I'll just see if we can make up a nasty little question. And one of my other favourites that come out is this one. I've got a cyclic quadrilateral. Let's just draw in my cyclic quadrilateral. I'm going to mark the centre as well. Let's draw in a radii there and a radii there. And I'm going to label O as the centre. And now we want to have a look at these angles. And we're going to be given one of the angles. So let's suppose this angle I'll label as I know what we have. 110 there. Have I drawn it wrong? I have. I can do this one. It's going to be a lot more difficult. I'll draw another one. It's going to be easier. Because I was going to show you my favourite one. I just drew it wrong. Problem with live videos. We'll draw the same thing in again. I'll try the other way around, it'll be quicker. here we go. I've got angle up here. Let's call it X. I'm going to have this angle here. Let's call this 110. And I've got angle Y. And I've got to find what the different ones are. We've got a cyclic quadrilateral, so I know that angle X and angle Y add up to 180 degrees. We've also got one of these shapes where the angle at the circumference is half that of the angle at the center. This is why I wrote this one out two different ways, because it depends what we're looking for. So I can say that angle X is going to equal 55 degrees, and the reason is because sometimes you can use three little dots the other way up to therefore, because the angle at the circumference is half the angle at the center. And so I know that's 55. If I know that's 55, then angle Y, because it's a cyclic quadrilateral, which we've stated already, is going to be 180 degrees minus 55, which is going to give me 125 degrees. And there I've worked out some of those. So I spent just a few minutes looking at circle theorems with you and having a look at a few other problems. Every problem you're going to get is going to be completely different, but the idea is you break it down bit by bit, and in doing that way you can solve the problem. So I'll see you next week and we'll have a look at some more maths problems, or if you're interested in watching some science, have a look at some of the other ones. And I'm doing chemistry, physics and biology on the other days, so have a look at those. If you like them, then remember to subscribe. I'll see you same time next week. Bye-bye.